So how we will build the spine inside our branch? We have our branch with scattered points on it, and we have a steps value based on the gradient, so it's like 60 step. We will create a for each point loop and take this u, v, w values and load this point clouds. So we get our first point cloud. We will use a fuse to snap all points in the middle of this point cloud, then find the minimal distance across all these points till this center and use it like a width attribute, and then use add sop to create. So we are getting these points here, 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 here. So we will use add sop to create a line, and we get a spine inside each branch. Let's start. Let's create for each point loop. Enable multithreading. Use UVY attribute. And let's see. Yeah, so we get our point cloud. Let's create a fuse SOP. And use a snap distance 3 and not snap fused points. So we need all points in this center. So this our point cloud, and this our points, 93 here, 93 here. So now we can find the minimum distance. Let's create a point triangle. And the vector cos equal point 1. So we take a position of that pt num of all points in the second input. So we have a same count points here and here in this input and this. So we can use at pt num here and create f dist attribute equal distance between our current position and position. And we have this distance attribute. Let's promote our distance to detail as minimum. And we have a minimum distance. And let's create a width attribute. Create a point triangle. Now float at width attribute equal detail 0 distance. Let's check. Yep. And let's remove all points except one. If at pt num not equal 0, remove all points. At pt num. And let's plug it here. Let's check. So we have our points. Let's template our, and probably to avoid this curve, let's fit a little our gradient. So use fit 0, 1 because we know that uv.y from 0 to 1, and paste it 0, 2 and 1. Yeah, to make it a little more straight. Great. Next, add SOP. and we get a line. And nice thing that it starts from 0, so all root points of each branch will be 0, and it's help us in the dynamic section. But it's a lot of points, so wire solver doesn't like a lot of points. It will long time for calculation. So let's resample it. And we need to check something because here it's still a lot of points with this resample value, and here it's like 200. Yeah, it's okay. Okay, count of 400. Let's see the smallest one. Yeah. So what we can do, we can measure the length of this line and use this maximum and minimum length across all the tree to fit the resample length. Let's create a measure attribute here and use a per piece and use a branch ID because there is a branch ID. And let's check why it's not working. Oh, it should be perimeter, not area. Yeah. Okay. Now let's disable resample and check 0, length 15, and 400 to 434 to, oh, maybe let's see. Let's see all the tree with minimum and maximum value. Come on. Yeah, let's force compile. So what we have here, 147 and 15. Yeah, 147 and 15. So let's resample it. Here, add a spare input because you can reference to other nodes inside compile block. So put it here and type here fit prim input -1 0 primitive perimeter 0 and from 1 to 15, and it will be 0.2 till 1. Oh. Huh. Oh, prim. Yeah, not prim. It's prim. Yeah. Let's check. Yeah. Looks nice. Let's switch to biggest one. Yeah. Okay, let's see on the all tree. Let's make a force compile. Yeah, looks cool. Okay, so next what we should do is copy all attributes from our branch to our spine. Let's create attribute copy paste it here, and connect, and copy branch ID, level, and name. And let's check. Yeah. Okay. Let's see what we have. Great. We have a name, branch ID, level, all attributes on the place. Cool. Let's template our geometry first to see if all branches has a spine. Yeah, looks correct. Cool.